Uh, got something special for y'all today. A little bit of story time with me. When I was a wee lad, my dad would do this thing where he would set up a VCR with a blank tape to record whatever was on TV. A lot of times this was stuff he was personally interested in or wanted to rewatch or wanted to have around for us. Stuff that was educational, stuff that wasn't. If a movie would play on TV, he would take advantage of that because blank tapes were cheaper than buying the actual movie. I don't condone piracy, but this was basically piracy in the 90s. Um, and one of the specials I distinctly remembered was the Extinction Files, which was a special that first aired on BBC in 1998 and then must have been on Discovery Channel around that same time because that would have been when I first watched it. I have not seen this since like 2002. I just happened to be like Googling it one day to see if anybody remembered it, and I saw someone actually uploaded it to a website. If you type in the Extinction Files BBC special, you'll find it in Google on the front page. I'm going to watch it and comment on it and kind of do a react sort of video with this, see how that goes, and I'll only leave in the parts where that I find personally interesting or either hold up really well or don't hold up at all that I need to chime in on. This is from the 90s, and it is a paleo documentary, so it's going to be a little dated in more ways than one, but we're gonna check it out. Like I said, I haven't seen this in probably 20 years, so yeah. Oh yeah, I can tell that they did the same exact thing that we did. This is what it looked like when you were record stuff on a blank VHS tape.
Almost all the species.
There it goes. Oh, that 90 CGI. Yeah, BBC. Yeah, this is a really weird framing device, if I recall. Really weird. It's Darwin. That fucking X-Files ass logo. Extinction Files.
Our fossil animating time machine.
Fossil animating time machine.
It's a device that plunges down a shaft into the past, turning back evolution's clock as it goes. Right at the bottom is the level where life began, nearly 4 billion years ago. The machine will rise up from there, stopping at various prehistoric times, and with a laser chisel, mining the past, cutting out fossils and bringing them to life. It resurrects the creatures.
Dunkleosteus. Oh man, that is some derpy looking.
Then it shows what killed them off. It shows their extinction.
Yep. Hence the name.
Extinction has become a bit of a dirty word, but in the big picture, extinction is a normal part of the evolution of life. Of course, extinction is bad news for the species that dies out. But when a species becomes extinct, it opens up a space for some other species to evolve. And in the long history of life, we can see now that extinction is a very normal part of the evolution and diversification of life.
In other words, if it hadn't been for mass extinctions and the explosions of life that followed them, most of the 50 million species that now exist wouldn't.
Pretty apt comparison, going from an ichthyosaurus to a dolphin. Same ecological niche.
Extinct ancestors. Humans too. You can take a human and, using fossils, trace back to an amphibian.
A lot of stretching you gotta do there.
Before fish.
Haiku ichthyes? Is that what that haiku ichthyes?
You can go back to the time when life on Earth had just
Not gonna lie, this song kind of slaps. Trilobite. Had to get some CGI smoke because that was one of the first things that we kind of figured out how to do in CG.
It was a very different planet than the Earth today. Imagine a planet with a moon 4 times larger
Jack
than the moon we're used to, but a sun only 3/4 as bright. During the day, which was short, probably no more than 15 hours long, the sky would appear pinkish brown due to organic haze in the atmosphere. If you walk, you might see some organic film along the side of the sea, but that's probably not where life originated.
That's one hole in. It's not a hole in the theory of evolution, but just a gap. Isaac Newton actually, I believe it was Newton, kind of came up with this concept called God in the gaps, where humans will never fully understand the intricacies of every single thing that happens, and in the gaps of those understandings, that's where you find God. One of those gaps in evolution is we don't really know why DNA involved in the first place. We can measure its effects, we can analyze DNA, we can analyze the genetic code of any living thing and find last common ancestors and how far back it would have had to go, but we don't really know how and why the DNA kind of generated from inorganic material in the first place. So just really interesting thing to kind of consider when debating science and philosophy, and how the two aren't as segregated as a lot of people would like you to believe.
First organisms on Earth were bacteria. We know this because we've got fossils that are 3.5 billion years old that are bacterial fossils.
That's crazy.
Remain with us today as the most diverse and abundant group. Each and every one of us carries.
I mean, it makes sense that bacteria come first. It's genetically the least complex.
That contain our own genetic material.
Bacteria dominated life then, and they dominate it now. But for a near eternity, bacteria had the Earth to themselves. If you think of the history of life as a single day, with the first cells appearing in the first seconds past midnight, the age the time machine visits now, the age of nothing but bacteria, lasted until 8:30 p.m.
For the first 80%
Dang.
of the history of life, evolutionary changes that we see are relatively undramatic. There are spheroidal and rod-like microfossils, but most of the evolutionary action is inside the cells that we can't really see.
Millions of years, cells had been taking the carbon out of carbon dioxide and letting the poisonous oxygen, poisonous to them, float free.
The accumulation of oxygen in the atmosphere...
The idea of oxygen being poisonous to something living is crazy.
Many of the lineages that had evolved
True, though.
into extinction because of these changing conditions. The conditions were changed so dramatically, in fact, that the chemistry of the ocean changed.
I don't know if it's just the resolution, but that dude's beard is crooked. Might just be the video resolution, but
The planet was becoming
you see that was like
and most of life,
at an
as
angle.
bacteria had always known it, came to an end.
One of the organisms that disappeared about 2 billion years ago from the fossil record is a tiny, funny-looking bacterium that's been named Cacabecchia. It looks almost like an umbrella with a ball at the handle end of it. Evidently, it was something that perished with the oxygenation. But it's very interesting that several years after Cacabecchia had been described, something just like it was discovered in a rather unpleasant patch of soil next to Harlech Castle in Wales, where people had been
I heard about
for several
this.
centuries, perhaps producing an environment
I heard about this in my high school biology class.
2 billion years ago or older.
But while the primitive bacteria were stewing in their own waste oxygen,
Yeah, we've actually been able to like just
that actually thrived
take soil and water and other unsanitary conditions to recreate ancient bacteria.
and there was a new form of energy in the world. Instead of just drawing on sunlight,
First
these
animals.
creatures could use oxygen to burn other creatures, to burn food. Life had reached a new...
Calories. Calories is what they mean when they say, like, burning food.
Starting the trip back up the time shaft, first stop is the period known as the Cambrian. 530 million years ago. And in the ocean...
In the Cambrian seas, there was our distant ancestor, Pikaia, the first sign of a backbone dinosaur.
Pikaia.
This was the ancestor of all the fishes and other backbone creatures. It shared the seas with a number of other very bizarre creatures like Ovidinia and the terror of the seas, the large Anomalocaris. Pikaia itself was a fairly insignificant animal, and it was pretty touch and go whether it might have survived.
Yeah, I'm pretty sure we
If it
found
had not,
older
it would not be here.
ancient fish. Like, I think Haikuichthyes
was running experiments.
is older
There were
now.
all sorts of strange body forms and ways
Fact
of...
check.
In time, a lot of them were weeded out, and towards the end of the Cambrian, only about 30 basic body plans had passed the test. Those 30 are still around, and no really new ones have been added since. But then, things like insects existed alongside designs that were never seen again.
That looks like...
The prototype for some
This
of
looks
the
like a
creatures
Windows
shared
screensaver.
with now defunct fierce predators. How the losers worked and what they looked like can only be deduced from the records in the rocks.
Most of which are just
But one
print
of the
fossils,
losers,
trace
lucky
fossils.
for us, was Pikaia, the granddaddy of all the animals with backbones.
Reusing footage there.
And the next stop is the age of the first animals with backbones, the fish.
And the other primitive fishes had evolved into a whole range of advanced types. These included some modern forms like sharks and bony fishes. But
Yep,
also
the
some
first sharks.
extraordinary armored fishes, which are completely extinct now. And these included the placoderms, which had a great bony shell-like
Dunkleosteus.
structure over the head. And the jaws were armed with very sharpened, bony structures. Some of the placoderms were absolutely huge. This one was 40 feet long.
Looks so derpy. Look at the eyes. CGA really has come a long way.
Another group of Devonian fishes were the lobe-finned fishes, and we still have some living fossil survivors today.
Yep.
Amongst these are the coelacanth, very famous living
Yep.
fossil.
Yep.
thought to be
Living
extinct for
fossil.
years.
Living
A
fossil.
sensation was caused in 1938 when one was fished up live off the African coast.
We thought the whole family lineage was
There are also living
dead for a
lungfish
long
as well,
time,
and
but
they can amazingly
then we found the
survive in water
coelacanth,
and breathe air.
which coelacanth itself, that species, has not been around since like dinosaur times, but it's
In
the
Devonian
cousin
fishes,
of
the
things
other
that were.
fishes evolved in a slightly different way, and their lobe fins evolved into legs, and this was a
Yep.
major turning point for our own ancestors.
Some of these creatures looked very much like a missing link between fishes with fins and animals with legs and fingers and toes. Essentially, they were just fish with legs.
I can't get over this derpy CGI.
Mainly for paddling about in shallow water, perhaps trying to escape from predators. It's perhaps no accident that it was lobe-finned fishes which gave rise to land-going vertebrates. It's to do with the structure of the fin and the skeleton which supports the fin.
So, from fins came legs, and from legs came the first footsteps on the shore. And from that, over many millions of years, came all the big animals in the world that ever flew, hopped, ran, walked, crawled.
Though, bit of a misnomer here, and they should have known better. This is an issue I have with a lot of paleo documentaries, both from this time, before and after, is that they tend to focus on, like, the descent of man angle, like everything building towards humans as the apex of evolutionary achievement. That's not necessarily true. Yes, we're top of the food chain and we've had a much grander impact on the planet than any other species could ever dream of, even ones that are around today that might have certain things that they do better than us. Ants have a greater brain to body mass ratio. Whales have bigger brains. They're also bigger animals. You have other things like bees that have a lot more complicated social structures. Octopus, the squids and octopi, they are born with the intelligence equivalent of a 5-year-old, but they don't live long enough to really get much use out of that. The first animals to step foot on land were not amphibians. They were arthropods. Sea scorpions, I believe, had land-dwelling cousins long before the Devonian period. Back in the Silurian and Ordovician period, I can never remember which one of those two came first. But they had ancestors already on land. And of course, you had plants by then as well. You have to have plants in order to sustain life above water. So a little bit of a misnomer, a little bit of the vertebracentric stuff going on here. And if I remember correctly, this actually continues. Like, I remember one thing I didn't like about this documentary when I was a kid, and I don't remember if it's actually the case or if it's just other things in this documentary kind of superseding my memory. We'll see when we get to the Mesozoic period what happens.
The sea was a going enterprise and was ripe for another big takeover. The huge placoderms, for instance, were among the fish that were on their way out. And the steam shovel mouth vanished forever. The clock.
They don't name Dunkleosteus in this.
Rises. And by way of a rare fossil
Should be in a
Scotland,
Carboniferous now.
beams into the Carboniferous period.
Yep.
The heyday of the fish that took the placoderms' places.
Now, I'd say their heyday is now. Nah, the dolphins are kind of, whales are kind of above them in most instances, but sharks are kind of perfect for what they are.
Rare discoveries, and here's one that just laid down and died and wasn't disturbed or scavenged or anything. The thing that strikes you straight off is this huge so-called spine brush complex in the place of what you'd normally expect to see the first dorsal fin, the first fin on its back.
Trying to see if they name it here.
The thing you'd normally expect to see cutting the water in some sort of horror movie where the shark's approaching the
Jaws or yeah, some sort of horror movie. I wonder which one he's referring to.
An ironing board with a bunch of teeth sticking off the side, supported by some weird sort of fibrous structure behind a massive bony cutwater spine at the front end.
A shark with a jagged-toothed ironing board on its back.
They're not naming the species for some reason. So I want to look this up.
What on earth for?
Because
No living
even though
fish has anything that resembles this spine brush complex. Perhaps it was like a remora, one of these fish that today catch a lift on the underside of bigger fish with a sucker on top of their head. That's a nice idea, but I don't know anything that hooks in using these scale-like structures. Sharks primitively had spines, which function as cutwaters at the leading edge of the fins, but these also have a defensive function. today's sharks, you find the spines. Many of them have venom glands in the back. So if you take a mouthful of a little spiny dogfish or a Port Jackson shark or something like that, you'll pretty soon want to spit it out rather than having a spine stuck in a palate.
So, was that it? A device to discourage Carboniferous swallowers? Well, some other fossils of a similar kind of shark have been found on the other side of the world, complete with ironing boards.
Alright, so they're kind of skipping over it. Alright, so I have it pulled up here on Wikipedia. It's the Stethecanthus, shark-like cartilaginous fish, lived from the late Devonian, yada yada yada. So it's not actually a shark. And we've known about it since 1875. Holy. But yeah, even though it looks like a shark and it would be a cousin of the sharks, it's not actually a shark. But yeah, Stethecanthus is, if you want to look more into that, that's the name of the thing.
The fossilized females don't have them.
So they're suggesting it's a display structure.
And that made Mike and his colleagues think.
Kind of weird for a fish to have.
Think that maybe it was a secondary sexual character. It was something like a peacock's tail. If you could support a huge flamboyant device like this, you're looking pretty fit.
I mean, it tracks.
These things would think,
When in doubt, it's a display structure.
look at the fin on that. You know, he's got some energy to spare for offspring or whatever.
God, that's some janky animation.
Sharks today court before they mate. But whatever the female is looking for in the male, it's a lot subtler. No sharks today, anywhere, have display paraphernalia.
Yeah.
Just teeth. The ironing board shark, of course, went extinct. But why?
The modern sharks have more sophisticated ways of swimming. They've got better fins, they've got
Yeah, that's why
mechanisms, and they've got more highly evolved.
Fun fact, that's why modern sharks actually outcompeted the megalodon.
Active exclusion.
Sharks are built for speed and
One of the Earth's regular
like,
sea level changes.
sprinting speed.
Watery habitats have a way sometimes of just draining dry, and evolution is often driven by plain bad luck. Because coming up next was the mother of extinctions.
They're gonna get into the Permian after the commercial break.
Permian period, 245
Yep.
million years ago.
Trilobite.
10:30 p.m. on the Life in a Day clock. For millions of years now, life had been slowly and steadily branching out. No mass extinctions for a long time, and a rich, many-species world had developed. Trilobites, starfish, sea urchins, and lots of different kinds of fish. Land life was booming too. The air...
Oh, that's some blurry footage.
And the new big plants crawled with them. It really was a high time for insects. There were dragonflies, for instance, that were almost exactly like the dragonflies of today. Except that they had 2-foot wingspans.
This was not in the Permian. This was in the Carboniferous.
To eat this bounty, there were such things as reptiles, which had come a long way from the old 4-footed fish.
Yeah, reptiles also first came about in the Carboniferous.
The ancestor of humans at this point was what's known as
Ancestor of
mammal-like
humans.
reptile.
Mammal-like reptile.
They have been warm-blooded. May even have had hair. One of its relatives, a sort of ancestral uncle, was Lystrosaurus, a thing that ate plants and was about the size of a pig.
Lystrosaurus.
But life was no
Pretty sure
easier
Lystrosaurus itself was much smaller than that.
because where there are plant eaters, there are always plant eater eaters.
Plant eater eaters.
One of these was the saber-toothed reptile. This wasn't a perfect life, any more investigation.
Gorgonopsis, I think?
But it was alive. Until something happened.
By the end of the Permian, ecosystems...
Yeah,
in
I'm
the
gonna
sea and
fact
on land
check
are very
both
complex.
of those. Yeah, as you can see, Lystrosaurus, the larger species were pig-sized, but most of them were, more cat or small dog-sized. And the saber-toothed reptile is Gorgonopsis. So they got the sizes right on those, sorta.
A whole range of sizes and shapes of animals feeding on each other in very complex food chains. But then something went wrong. There was a mass extinction, perhaps the biggest of all time, and it's
Yep.
estimated that something like
The Great Dying.
60% of all species died out. That means that's the closest that life has ever been to total extinction, total annihilation.
For example, all of the trilobites, and the trilobites have been the leading life form, were wiped off the Earth.
Crazy.
Most of the fish died. And the plants and insects were battered too. Out of hundreds of thousands of insect species, a third disappeared,
Dang.
including the magnificent giant dragonfly.
Which would have actually been extinct before the Permian period, but okay.
Almost nothing was left of the mammal-like reptiles.
Well, there might have been dragonflies that size in the Permian period as well.
What in the world
What?
happened?
This is a little frustrating, because they're not naming the genus. They're not naming Gorgonopsis.
During the late Permian was
They're
that
just
all
using the
continents on Earth were moving together
nicknames.
to form a single supercontinent called Pangaea, and the effect of that on life would be pretty catastrophic.
As the continents collided, whole seas disappeared, especially the life-rich shallow ones. But how much damage can continental collisions really do? This one took 10 or 20 million years. Even evolution can sometimes keep up with that. Sea level change, though, can be quick, and can wrong-foot species before they're able to adapt to it. Volcanoes are
That's a
even
big
quicker.
worry with
Another
the climate change models.
was that it may have been caused more catastrophically by a great volcanic eruption. And there's a lot of
People
evidence
more
now
worried
from
about the sea
Siberia
level
and
changes
east
than
of
the
Russia
actual temperature
that
changes.
There's a huge phase of volcanism happening at this time, where billions of cubic kilometers of basalt lava were spewed out all over the Earth, and it covered an area something like half of Russia, an absolutely vast area. And the effects of this eruption would be enormous, not just in that local area, but worldwide, because of course when a volcano erupts, all kinds of gases and dust are injected up into the atmosphere.
The world would have become dark, dirty, suffocating in sulfur dioxide.
Sulfur dioxide, one of the effects of that is it's an aerosol, and if it gets erupted high enough into the atmosphere, it can actually induce cloud formation and, in fact, produce darkness, and maybe darkness on a global scale. So one extinction mechanism would have that. It'd have short.
A lot of the geologic
global
time
darkness.
stuff in this is at least
Several
accurate.
years after each of the major eruptions that we see in Siberia, obviously with the catastrophic effects of shutdown of photosynthesis, and basically everything dies.
Sulfur dioxide cools the planet. But volcanoes also produce carbon dioxide.
Carbon dioxide actually has an opposite effect. If you pump lots of carbon dioxide into the atmosphere, then basically you make the planet a lot warmer. The sheer volume of these volcanic eruptions, we may have actually had a sort of a super greenhouse climate with an incredibly warm planet. Even the poles may have been very mild at this time.
Too cold, then too hot.
This was a catastrophe for most of life in the late Permian, but of course it was a success for others. There were winners, and some of them were quite unlikely. In the seas, for example, sea urchins did survive, and then during the time after the Permian, they radiated and they've become a very important group today.
What happens after a mass extinction is that the survivors mutate and proliferate, taking over the territory that the victims left behind, with forms of life that can handle the new conditions better. The human ancestors also made it through, along with a few other mammal-like reptiles. Uncle Lystrosaurus, in fact, was still having a field day, roaming the plains like great flocks of sheep.
That's a weird reconstruction of
But at the end of
Lystrosaurus.
this period,
I've seen a lot of them.
Post-extinction, and another job lot of evolutionary.
It's a really sharp mouth.
Some of the surviving
Very
mammal-like
pointy.
reptiles were becoming reptile-like mammals. The first mammals. And other reptiles were discovering a different dimension altogether.
Alright, we're in the Mesozoic.
It's getting late.
This is
Around
my
11
field of
like
expertise.
the day clock. It's time for the Jurassic and Cretaceous periods.
Fuck the Triassic, I guess. Everyone always skips the Triassic. Even the Jurassic World Evolution
The
2.
Earth of the Cretaceous
It's
was
like
beginning
6
to be
Triassic
recognized in life
species, and
today,
only 2 of them are dinosaurs.
with mountains, deserts, forests, and flowers.
Pretty good, I'm guessing
Just that walking
Diplodocus?
around among all that were the largest land animals that ever lived.
Triceratops.
Mammals
Kind of
were there
conflating the
too,
Jurassic with the
but with
Cretaceous.
dinosaurs ruling the land.
Bit of an
they
amateur
ruled
mistake. And of course we gotta focus on the mammals.
What ruled them? A fossil found in a cave near Maastricht in the Netherlands gives a hint.
Maastricht. They're focusing on
40-foot
Mosasaurus.
reptilian sea monster. The mosasaur.
Mosasaurs, if you like, were the T-Rex.
I think this is
They were
Tylosaurus.
the biggest marine.
Close relative of Mosasaurus itself. It's the
They
closest in
opened their
size.
mouths, bit onto their prey, and then the pterygoid teeth were able to move like a ratchet within the skull and pull
It's
in
actually
the animal.
actually we
And
don't
because
know.
They were curved,
We
strong
know
with
that they're relatives
prey
of
wasn't able
lizards
to
and snakes,
pull
but we don't know
itself out
which
of the
lineage they actually came
therefore
from, and
saw
if they came
as
from
an
lizards,
escape
whether they were monitor
going into the
lizards
earth,
or
because it actually
iguanas.
helped in its own demise.
Most likely monitor lizards. The skull structure's the same. But the body structure suggests snake. And I think it's the
Among the
limb
prey
structure that
and
suggests
birds,
iguanas.
Certainly, turtles were part of it.
Archelon.
It was what I refer to as the original ram raider.
The mosasaur was an animal with a promising future. 10 tons of speeding, battering reptile. It was destined to have a long line of evolutionary descendants. And yet it vanished in a geological blink.
Yeah.
And turtles didn't. Why one kind of animal and not another? And why so quick?
Before they get into the theory that I guess was widely accepted at the time, not to sound like a mammalian supremacist, but mammals with their metabolism are just a lot better suited at that large marine air-breathing predator niches, because there's multiple niches within that umbrella, than reptiles are. In fact, at least 3 major lineages of aquatic reptile rose and fell. They came into being and went extinct all throughout the Mesozoic era. You had the ichthyosaurs, who came about in the Triassic and then died out during the Jurassic. You had the plesiosaurs, who came around in the late Triassic and died out before the Cretaceous ended. Like, they didn't even make it to the mass extinction event. And then, of course, you had the mosasaurs, who kind of came about during the late Jurassic and existed up until the end of the Cretaceous. But really, I think it's they got too big. They're cold-blooded reptile. I don't know if they were cold-blooded, but their reptilian metabolism just wasn't able to keep up with that size. Whereas modern-day sea turtles, sea snakes, the marine iguana, they're a lot smaller in size, so they're able to more easily get enough food to maintain that body size. That's why you don't see a whole lot of megafauna today, is because of deforestation and stuff that happened long before humans really came about. Humans actually suffered from this as well. Homo neanderthalis and the early Homo sapiens, they were a lot bigger, they were a lot stronger, but as resources kind of diminished at the end of the during and at the end of the ice age, pretty much every species of mammal or every family of mammal downsized. Bears got smaller, wolves got smaller, cats got smaller, elephants got smaller, rhinos got smaller, hominids got smaller. It wasn't until we developed agriculture and stuff that we started getting bigger again. And so, yeah, the larger size you are, the more powerful you are, the less likely you are to be hunted. But that comes at a high food cost. And I think that's what did the Mosasaurus in. It wasn't able to maintain its large body size, which is also, like I said earlier, what happened to Megalodon. Megalodon was too big and too slow to hunt down these whales it needed to hunt down, and it was getting outcompeted by the much smaller great white sharks.
According to standard views about evolution, as Darwin proposed over 100 years ago, most of evolution is gradual, with long-term change happening over millions of years. But occasionally, there are catastrophic changes when these normal rules seem to be suspended.
On the last day of the Cretaceous, probably the biggest rock of the last half-billion years fell out of the sky. This was
Hit the
rock
Yucatan.
about the size of Mount Everest.
It was, in fact, the end of the world. For them.
Very, very summed up view of the Mesozoic period. Not a whole lot there. That's what I always complain about, is that, like, oh, you spend all this time on bacteria and placoderms and mammal-like reptiles, but you give dinosaurs like 30 seconds?
Just unimaginable in human experience.
It's just weird. It's a weird thing for a paleo documentary to do. Usually dinosaurs is where the money's at.
And the energy produced by blasting off all nuclear weapons that the Earth has at one moment. The result of that energy...
We have a lot more now than we did in 98.
The largest crater that's been discovered in rocks in the last half-billion years. The pulverized rock in that crater would have been blasted into the upper atmosphere, completely enshrouding the Earth for at least 3 months. Furthermore, the kind of rock that was hit and just the chemical changes in the atmosphere produced by this rock falling onto Earth would have probably created immense acid rain. Combination of shutting off the sun for 3 or more months and acid rain falling onto the land, onto the ocean surface, probably shut down photosynthesis. Plants literally withered on the vine. The animals that ate plants would have starved. And
Yeah, large food shortage, the large herbivores go first, followed by the large carnivores.
Well, this is probably what caused the mass extinction of 2/3.
Though those looked like diplodocids, and they would have already been dead before this. The only sauropods that were alive at the end of the Cretaceous were the ones that were in South America.
For that asteroid impact, we've got a big crater buried.
And there might have been a couple in North America too.
In Mexico, called the Chicxulub crater, and that's just the right
Fact
size,
check on
just
that.
the right age to have been the impactor that led to the end of the Mesozoic era and the extinction of all those plants and animals. The problem with the impact is that there are, in fact, other asteroid hits. They're smaller, but not that much smaller, that don't seem to produce the same scale of disruption.
There's probably some kind of size threshold. Below the threshold, the planet can absorb the punch. Above it, all hell lets loose.
I mean, that's true of anything.
That astronomical punch wasn't the only thing happening around that time. Almost all of North
Yeah,
America
Walking with
was
Dinosaurs did a really good job explaining that, like, dinosaurs were already kind of hitting diminishing returns with their size long before the meteor hit. Like, they were already kind of, like, starting to die out a little bit.
million years before.
And there were a lot of other ecological changes that were messing with them.
These new eruptions are known as the Deccan traps.
The role of the Deccan traps in the mass extinction are still not entirely clear. There's no question they're an enormous eruption covering a large portion of northwestern India, cubic miles of volcanic material, and with that, the ash and gases that are always released by one of these major eruptions. But the Deccan traps begin before that mass extinction and persist after it, although there clearly is an intensification of the eruption at just about that time. Some people would argue that intensification was itself the cause of the extinction. Others would argue that perhaps that intensification actually reflects the impact. After all, the Earth probably rang like a bell when that impact occurred, and that might have somehow triggered or intensified that renewed vigor of those eruptions. The question is it plausible that an eruption even that huge could have done the job that we see in the mass extinction that we do? 76% perhaps of all living species extincted about this time. That's a very impressive loss.
That covers a lot more animals than just the dinosaurs. For instance, out in the ocean, the mighty mosasaur disappeared. Why? Why the mosasaur and not the turtles or the crocodiles?
The crocodiles and
Efficiency.
turtles lived in a freshwater food chain that was based on detritus, that is to say, organic debris. Bits of plant material, leaves and wood and other bits of dead animals that fed a food chain that would be more buffered from the mass extinction than the mosasaurs that had to ultimately depend on the photosynthesizing organisms that got their energy from the sun. So if the crocs and turtles could rely
A little bit of
on
a
organic debris that
opposite
would be
there.
fed into their ponds and streams,
I don't think there's any evidence
then
to
perhaps
suggest
they'd
that
have
it,
edged
like,
during that mass extinction.
disrupted
Another possibility,
photosynthesis on
is
that level.
Smaller turtles and smaller crocs had at least the potential to hibernate.
If mosasaurs had entered the rivers, I'm almost certain they would have survived. Mosasaurs
That's
were
kind
not
of what the monitor
They were
lizards are.
highly successful animals.
The Komodo dragon, the Nile monitor.
For the
Basically
winners,
what they are.
struggling out of the smoking ruins of these mass extinctions, the world has been handed to them on a silver platter, and there's this evolutionary scramble to reoccupy that world. These recovery periods are crucial intervals in the history of life because they represent the time when the bit players suddenly move to center stage and can diversify without any sort of limits. And these are where new evolutionary breakthroughs occur.
At last, after 200 million years in the shadows, the way was clear for the mammals to take over the Earth. Not quite. Not just the mammals. In South America, there was another kind of animal with direct dinosaur lineage that also survived the asteroid, the volcanoes, and the long, cold darkness.
Yep.
A bird.
Gastornis. Considering that it's South America, it would have to be Gastornis, right?
The clock, 11:36. The period, the tertiary. The creature, the terror bird. A 10-foot tall flesh ripper with sturdy, unbirdlike.
This was widely accepted for a very long time. But this is specifically what I was talking about when I said that there were things that were in the special that were dated. I always remembered this, and I didn't find out until like a year ago, and maybe we as you know, scientists didn't really figure it out until a year ago either. But they weren't flesh rippers. The terror bird moniker is a misnomer. They ate fruits and nuts mostly. They were like giant walking parrots. And that jaw, and you can kind of see it here because, like, yeah, that's a really sharp point. Like, I could totally see how that could, like, puncture. But this smooth curve and that kind of puncture-like structure, that's for fruit. That's not for meat. Like, that's not super efficient for eating muscle and flesh and crushing bone. Yeah, I just looked it up. It was apparently in 2012 and 2014 that studies were done on its skull structure and possible feeding habits. So this was in 1998. Gastornis was described in like the 1890s. You know, you had 100 years of precedent. That's not going to get overturned overnight. Which is why I'm saying, like, this is data. Like, this was understood as fact back then. It was widely accepted at the time and for another decade and a half after. I, for one, champion documentaries staying as up to date as possible, and since this is a video that is educational in nature, even on my part, I can't just let that slip, or I can't just let that slide. I have to point out the fact that Gastornis was an herbivore, possibly an omnivore. It possibly ate, carrion, and possibly a scavenger as well when opportunity provided itself. But yeah, it was not a meat eater. The terror bird moniker is a misnomer.
Bones and legs and feet for running fast.
They really came in 3 different sizes according to bird standards: large, very large, and gigantic. And they were a lot like ostriches, but if you would have seen one of these alive, you would have noticed one big difference, and that would have been its head. Its head is much more eagle-like or hawk-like, indicative of something that would eat meat. But they were about the same size as an ostrich, long-legged, able to run fast on the open plains of South America, and probably run down small animals and feed on them. It's really difficult to figure out how these birds were living because
Secretary
really
Birds
nothing that's
rule.
like them today. To do that, what we have to do is look at things that are similar to these terror birds. For example, the secretary birds that are alive in Africa. And these are birds that are much smaller than the terror birds. They don't really have the large size and large heads, but they're also predators. They feed on small mammals, on small reptiles, and are fairly long-legged and live fairly similar to how the terror birds probably did. When
I probably mispronounced a bunch of stuff in this video already. I can't judge.
Then would have had the same point of view. It was a time and a place where the birds were big and the hooved animals were small.
Little horse. That is a decent reconstruction in Gastornis. You know, carnivorous attitude aside. In fact, that might be the best looking thing in this documentary so far. They even kind of textured the feathers a little bit. Oh, that animation was so janky though. Yeah, I posted this screen cap on Twitter the other day.
To work out why the terror bird died out, it helps to know how it evolved in the first place. South America at the time was just a big island, a place where evolution
There's a whole
could carry on
continent
undisturbed by anything that was happening anywhere else.
Throughout most of the Cenozoic in South America, there were basically 2 main groups of predators. You had these marsupial predators, some of which were maybe bear-like. They weren't very well adapted for running long distances. And some of these saber-toothed animals that look like saber-toothed cats but weren't, they were marsupials. And then we had the birds, on the other hand, which were probably the more fast-running, swift animals that would be able to pursue their prey. These two lived, to some extent, in coexistence up until about 2.5 million years ago, when something really interesting happened. And that is the Panamanian land bridge, which is a connection between North America and South America, came into existence. When this came into existence, all havoc broke loose to some extent. It opened up the way for South American animals to go up into North America, and for North American mammals to come down into South America.
Which is why there's cats in South America.
North went south, south went north.
And why there's armadillos in North America.
Overhead.
Armadillos first cropped up in South America. And then journeyed north.
Climatic change. The Andes Mountains were rising higher, and the connection of the two land masses stopped water flow. And ocean currents affect large-scale patterns. We know that with things like El Nino today. We get an El Nino and it changes the weather. You can imagine connecting two continents, what sort of effects that has on the weather.
Mm-hmm.
The change in the weather meant a change in the landscape. Dryish grasslands, good for long-legged running things, gradually turned into thick, wet foliage. And animals that could store...
Jaguar, one of the coolest freaking animals.
Or live in the trees. North American type predators, not birds, not marsupials, but so-called placental mammals, mammals that didn't carry their babies in a pouch, made themselves at home. And there was no home left for the terror bird. But while one continent turned into forest, part of another, Africa, turned into plains. Apes there had to evolve and adapt, and the result, at 7 seconds
we're
to
getting
midnight,
at the
was a new force for
origin
extinction.
of man.
Early humans lived in a world of unprecedented richness, surrounded by a huge range of large animals. As they spread across the world, these early humans brought fire and agriculture and hunting. At the same time as they were spreading, many of the large animals died out. For example, in North America, 57 species disappeared, including the saber-toothed cats, the giant sloths.
Am I allowed to show this?
One human talent was a prodigious ability to travel. And as people spread across the planet, many of the planet's big animals went the way of the dinosaurs. But was it the humans' fault?
A lot of people think that humans are responsible for the extinction of the mammoth and the other big game that went extinct at the end of the Ice Age.
A little bit, but
Here were
like
all
I
these
said, it
wonderful
was...
big game,
They're
just
just
waiting
too
to
big.
be
They're too big for their own
slaughtered,
good.
slaughtered
Too big
and
to
so on, as
sustain
people swept
themselves.
down the continent, really destroying all before them. And this is the so-called overkill theory. When you've got a population of millions of animals to become extinct, the odd individual being hunted is not going to be the answer. So the evidence, I believe, is rather circumstantial.
As soon as humans settled in a new place, the big animals there began to topple over.
Except
There were
Africa.
10 million humans in the whole world then. Could it just be the old climate again?
There's
Yeah, a
another
lot of it
school
was
thought
climate.
which says that the extinctions were nothing to do with humans, but they were caused by climate changes.
Humans
When the
certainly
climate
didn't
warmed at the
help.
end of the Ice
You
Age
know,
and began
tell
to
as old as
rise
time.
population,
Still happens today.
This tundra steppe habitat
I don't know about us
vanished.
causing
And
climate
it was
change,
replaced
but
by
we're
what we have
certainly
today.
not helping
In the
it.
far north, we've got the real tundra, which is a very
I don't think we
low
can.
nutrient kind of habitat. It can support a few reindeer and musk oxen. There's no way that it would provide enough food. For
I don't
herds
think
of
we're...
cows and
Our
horses
technology is powerful
and
enough to
rhinos and
reverse
so on
climate
there
change,
in the Ice Age.
let alone cause it. I think it's happening whether we want it to or not. We need to just be ready for it.
There is a twist to the mammoth extinction story because until just a few years ago, we thought that the mammoth had gone completely extinct globally by about 10,000 years ago. until some fossils were found on one small island off of the north of Siberia in the Arctic Ocean called Wrangel Island. And the radiocarbon dates on these mammoth fossils turned out to be as young as only 4 or even 3,500 years old. It's quite extraordinary because it means that this last population of mammoths were still living at the time when the first Egyptian pharaohs were building the pyramids. So we have a quite extraordinary overlap.
You've seen that factoid on Facebook, I'm sure.
I think there's a parallel here between what happened to the mammoth and what may be happening to the Asian elephant today, essentially being a forest-dwelling animal. So in that respect, it differs from the mammoth, which was an open-ground animal. But the principle is the same. And although we believe that the cause of the tundra steppe disappearance was natural, if you like, whereas the loss of the Asian elephant's forest habitat is human-induced, there's certainly a parallel there. And we should be aware that if this continues, the Asian elephant may go this way.
Yep, it wouldn't be a 90s special without a Save the Rainforest message. I'm all for environmentalism, by the way.
Innocent. But it doesn't follow that modern humans, all 6 billion of us,
I'm just also, as an environmentalist, I'm aware of the conservation efforts we have been taking since well before the 90s.
Between mass extinctions, about 2 or 2.5 species become extinct every year. Number of new species is just a little bit larger, maybe 3 species per year. And the vast diversity that we have on Earth today reflects the hundreds of millions of years during which new species have been forming. But when we look at the modern biota, we find that species are becoming extinct at much, much higher rates than the average. It's not 2 or 3 species per year, but perhaps as many as 20,000 species per year.
Deforestation, hunting has been a big issue in the past.
As humans expand and consume without upper limits, other animals shrink towards the ultimate lower limit. 0. But what about us
Yeah, the
ourselves?
dodo.
Could we, in the end, do a dodo?
Humans have only been around for less than 500,000 years, and yet we know that the average shelf life of a species is maybe 1 to 10 million years, so maybe we have a rosy future ahead of us.
It takes something really drastic.
But in terms of planetary dominance, we're the most successful single species ever to exist. And some
Like,
others
we'll outlast
well
any other
along for the
species.
ride.
Just because we've already been able to adapt to pretty much any environment on the planet.
Wheat and rice, cats
And it's
dogs,
only going to get up from there.
house mice, all the domestic creatures. Humans are so dominant on the Earth today, and all the organisms that we keep for agriculture are, of course, highly successful in comparison to many wild species. But then there are all the parasites and other organisms that we support, mosquitoes and internal parasites and heaven knows what.
To this animal,
Yeah, it would either have to be like
godsend.
nuclear holocaust,
If you want to be a
a
survivor,
virus that just
greediness is the key to it all.
is specifically adapted to wipe us off the planet,
Be ready to
or
reproduce at the drop of a hat at a moment's
the
notice, whatever
heat death of the planet. Like, those are the only 3 things that I can think of that could actually wipe humans out at this point.
It's
With how
the
far our
species
technology has
and
gotten.
rats that will probably be the ones to pull through the next big extinction
My money's on the parrots.
when it comes.
Yeah, my money is on parrots and other, like, birds taking the top spot once humans kick the bucket. Not that I'll ever be able to cash in on that. Yeah, with our radars and stuff, a meteor wouldn't even wipe us out. We'd have too many people in too many bunkers and too many missiles to fire at the thing to diminish it. But yeah, that was the Extinction Files. I don't know if I'll ever do this for any other paleo documentaries or anything like that. I just had to find this one, and it happens to be from my childhood. I have a lot of distinct memories with it. Not as many as I would have thought, given that I have a pretty good memory, and I'm sure I watched this at least a dozen times growing up. But, yeah. Like, comment, and subscribe for more, paleo goodness, and also maybe memes and other analysis on other literary concepts. Who knows? My muse is a fickle thing. It can change on a whim. Have a good day.